In this video, we are going to focus on the end behavior with graphs, and then we'll also talk about solving quadratic equations and just kind of refresh your memory on that. So for our first problem right here, the first thing that I need you to notice, and this is really super important, is the fact that there's an x squared and an x. Anytime that there's x squared and x within the same equation, your options are to factor, if possible. You can do the quadratic formula. You can graph, and then you're looking for x-intercepts. So these are your options here. When we get into other ones where we have just an x squared, we can solve it totally differently. So let's go ahead and use the quadratic formula in order to solve this. Now the reason I'm doing that is because I know with factoring, we've kind of spent time doing that already, and this one isn't factorable anyway, which you wouldn't know quite off the bat. But anyway, so let's go ahead and do quadratic formula. But in order to do quadratic formula, it has to be set equal to 0. So to make that happen, I need to add 4x to both sides of the equation, which gives me x squared plus 4x equals 4. And then we have to subtract 4 from both sides of the equation, leaving us with x squared plus 4x minus 4 equals 0. All right, so to get our quadratic formula, remember our song, and I'm not going to sing it on here for you, although I know you really wish I would. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, we're looking at our information here, and remember your a term is your number in front of your x squared. So since there's nothing there, that would be a 1. Your b term is going to be your 4, your positive 4, I should say. It's a positive. And then your c is negative 4. So anywhere you have a c, you're going to put negative 4. Anywhere that you have an a, you're going to put 1. And then in the places where you have b, you're going to put a positive 4. That one's really light. I don't like it. Okay, that's better. So B here and here. Make sure that you use parentheses. Oh, I left out an A. Oh, poor thing. There we go. So you need to make sure that you use parentheses when you're plugging everything in, just to ensure that you do not miss any signs. So let's start with x equals negative. I'm going to put the 4, that's our B, in parentheses, plus or minus the square root of, parentheses again around the B squared, minus 4 times a, which is 1, times c, which is negative 4. And that all goes over 2 times 1. And then from here, let me scroll down a little. We need to simplify as much as we possibly can. So we get x equals negative 4 plus or minus the square root of 16, and then we get plus 16 over 2. So as we continue on simplifying, we get x equals negative 4 plus or minus the square root of 32 over 2. But remember, you always have to simplify as much as you possibly can. And at this point, you can use the calculator to simplify because I'm going to kind of jump ahead. So this comes out to 4 times the square root of 2 over 2. And then when you take it just a little bit further, you end up getting x equals, and the reason we can take it further is because this, and this, so all three, triangle, they're all divisible by 2, and so I'm going to divide everything by 2, giving you negative 2 plus or minus positive 2, and this square root we do not divide by because this is not under square root. And this would be your 2 answers, because remember, one of the answers is negative 2 plus 2 times the square root of 2, and the other one is negative 2 minus 2 times the square root of 2. In problem number 2, you'll notice that we only have an x squared. When you only have an x squared, you treat it like a regular equation. So treat like a regular equation. So you are going to subtract 14 to begin to isolate your 3x squared, and you get 3x squared equals negative 6. You divide by 3, and you get x squared equals negative 2. And then we have to take the square root on both sides of our equation. Now when we do that, we have x equals the square root of a negative 2. Well, any negative under a square root means that you have an I that comes out front. So we have I times the square root of 2, and that would be your answer. Now, if they were looking for real solutions, remember that this is imaginary, which means it's not real. So if they were asking for that, you may have to put that there are no real solutions for this equation, depending on how they write the answer choices. All right, number 3. Now you'll see again x squared and x. So we have to do quadratic formula or factoring, and I'm going to go ahead and go with the quadratic formula. All right, so we first of all need to have it set equal to 0. So I'm going to subtract 2x from both sides of the equation and get 3x squared minus 2x plus 12 equals 0. Remember also that you want it in standard form. You don't just want it, in any order, because you want to make sure that you have A, B, and C listed correctly. Then write out your quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2, what? 2a. All right. So negative. Now plug in your b, which is negative 2. So be really careful with that negative of a negative 2. So when you're plugging these in, this whole thing here is your b, but you're only putting it right here. Now when you go to plug it in here, make sure that you use parentheses around it. It's really important, especially when you type it into the calculator. If you put negative 2 squared in the calculator without parentheses, you get an entirely different answer. All right, and then a is 3 and c is 12. So we put that all over 2 times a, which is 3. All right, so as we go through and simplify here, a negative of a negative 2 is a positive 2, plus or minus a negative 2 squared is a positive 4, and then 4 times 3 times 12 is 144, so minus 144 over 6. And then we need to actually subtract those, so we get x equals 2 plus or minus the square root of a negative 140 over 6. All right, now right here, we have a negative under our square root, so we need to take the I out. So we're going to write I here, right directly in front of the square root, and make the 140 positive and put that over 6. And then we have to take the 140 and simplify it as much as we possibly can. And so I didn't actually do this one ahead of time, so it's going to take me a minute to figure out, because I don't have a graphing calculator on me, I just have my phone calculator at the moment, and I do not have this one memorized. So hang on just a second. So 140, Lord help me, 4, there it is. All right. So this comes out to 2 plus or minus 2i times the square root of 35, and this all goes over 6. All right, and again, you can do that square root of 140 in the calculator. So if you have the graphing calculator, you can put it in that y equals section. And then we can simplify just a little bit further, because our 2, 6, and 2, so our little triangle here, are all divisible by 2. So 2 divided by 2 is 1. Plus or minus, that's not the right purple. That's upsetting. I gotta keep it consistent here. I don't like it. 1. There we go. Plus or minus. 2 divided by 2 is 1, but we have I, so we don't write 1i. We just write I times the square root of 35. And then 6 divided by 2 is 3. And those would be your 2 answers for this problem here. And that was an awkward rectangle. Sorry. All right, number 4. We only have a squared term, so because we only have like something squared, we treat it like a regular equation. So I'm going to start with dividing by 2 on both sides of my equation to get x minus 1 squared equals 4. You take the square root of both sides of the equation, And when you do that, your square and your square root undo one another, leaving you with x minus 1 equals, and the square root of 4 is 2. And then we add 1 to both sides of our equation to get x equals 3. And there is your answer. All right. Now, at this point right here, the one thing that you do have to keep in mind is when we took that square root of 4, it could be a positive 2 and it also could be a negative 2. And so you do have to be really careful and ensure that you have all of the possible answer choices that would work in this scenario. So if we put a plus or minus 2 here, that would also mean we have the equation x minus 1 equals negative 2. And if we add 1, then we get x equals negative 1, which also works. So this would be a second solution to that equation. So just being careful and mindful that you don't forget about that plus or minus, because initially I totally did. You know, it's been a while. So just be careful with that. All right, and just remember that this one, I didn't use the negative here. I treated that one as the positive only. All right, now 5, 6, 7, and 8. I want you to do those. Now the reason is because you can use the app. So push the apps button on your calculator. You're looking for polysmalt 2. From there, this is your A2, or I'm sorry, A1? I don't remember how they have it listed. A2 and A3, or maybe it's backwards. I can't remember, but the way that it's on the calculator. But those, you just put those numbers in. Don't forget the negative goes with the 17, but you're looking for your two answers here and here, negative 3 and negative 2/5. And then same thing here. So go to your apps, go to polysmalt 2, and then work from there. I want you to get used to using that app. Describing the roots, all you have to do is graph it, and if you look at the printout of this sheet, it explains to you what you're looking for your graph. So I want you to do that with 7 and 8 as well. So let's quickly look at some end behavior problems, just so we can get through some more stuff in a shorter amount of time. On that sheet that I gave you, it tells you that you have to look at your highest exponent. Well, your highest exponent is even. And when it's even, that means your ends go the same direction. So they either both go up or they both go down. Well, going up depends on this first number here. Well, this would be how the ends are going to go because your first number is positive. So since your first number is positive, it's going to start up here and do something in between, and it's going to end up here. So these two are your end behavior. So as x approaches positive infinity and negative infinity, the y, no matter what, is always going towards a positive infinity. So again, it's because of the positive number in front means they both go up. The even index means they go the same direction. In number 2, this time we have an odd index. So we have two options. It could start down and then end up, or start up and then end down. And what you look for is this number right here, the negative. Well, the negative means that instead of increasing the whole time, it's going to decrease. So it's going to start here and do something in between and end down here. And, it's a fifth root. It may have a couple more turns than that, but the main idea is that it starts in this side, it does something in between, and it ends down here. So when you're looking at x approaching a positive infinity, which is this quadrant down here, f of x is going towards a negative infinity. And so again, this graph, it may do something totally different. It may, go like this and curve and curve and curve and then come back down like that, or who knows. But as long as you know where the ends go. All right, number 3, again, you're looking at your index. It's even, which means your ends go the same direction, but this is negative, which means they both go downward, so here and here. So here's your end behavior, and you would write that as your answer. And then with number 4, you have an odd index, so they go opposite directions, but it's a positive number, so it's going to start down here and do something in